An action potential is the change in electric potential associated with the passage of an impulse along the membrane of a muscle cell or a nerve cell. The building blocks of the nervous system, which perform action potentials to relay information throughout the body, are called neurons. When a stimulus is introduced, a signal travels through the neuron in the form of electrical impulses. Like any other type of cell, the neuron has a cell body. An impulse, after entering the neuron through the dendrites, travels through this cell body, which has a nucleus. The impulse then travels through the axon, which is insulated by a myelin sheath. The impulse finally leaves the neuron through the axon terminals chemically by way of neurotransmitters and stimulates either the next neuron or the target tissue. An action potential is completed using different mechanisms and particles both inside and outside of a neuron. These include acetylcholine-gated sodium channels, potassium ions, voltage-gated calcium channels, voltage-gated sodium channels, voltage-gated potassium channels, sodium ions, calcium ions, acetylcholinesterase. A large number of voltage-gated ion channels are found in the cell membranes of neurons, which allow for the movement of sodium ions, potassium ions, and calcium ions in and out from the cell during an action potential. When a stimulus depolarizes the membrane to the minimum threshold of activation, voltage-gated sodium channels are the first ion channels to open. As the sodium channels open, some sodium ions rapidly enter into the cell. Voltage-gated potassium channels open in response to the depolarization caused by the sodium influx. The movement of potassium ions out from the cell repolarizes the membrane back to its negative resting potential. In the neuron, voltage-gated calcium channels are only found in presynaptic terminals. Activation of voltage-gated calcium channels allows for the movement of calcium into the cell. Calcium entry triggers the release of stored acetylcholine from vesicles in the presynaptic cell. A synapse consists of the presynaptic terminal of one cell opposed by the postsynaptic membrane of the next cell. The small gap between these terminals is called the synaptic cleft. Acetylcholine is released from the presynaptic terminal, then binds to and activates acetylcholine-gated sodium channels, which allows for sodium entry into the postsynaptic membrane. Acetylcholine is rapidly degraded and inactivated by acetylcholinesterase in the synapse.
The process continues as the new stimulus once again causes the sodium channels to open in the following neuron.